Good morning, everybody. I hope you are enjoying this conference as much as I do. It's always a pleasure to be here. My name is Zdenek, or I'm known as a Z. I've been working with APIs for not 22 years, like Daniel on CRL yesterday, but for quite some substantial time. I started at API, which was a design-first platform where I authored the API blueprint, one of the API description languages. Now, I left API when it was acquired by Oracle, and I started my own consulting, good API consulting, when I work with some very interesting clients, helping them on their API journey. But I'm also author of a data modeling tool called Supermodel. But today, I would like to talk about the API style. So I would like to give you a framework for what I think is a good way to think about how to pick the right API styles for your next API project. This is the continuation of the talk I was giving on this very same stage last year, when the popular topic was and still is, to some extent, REST versus GraphQL, right? Which one is best? Of course, we now learn that it's not the question which one is the best, but it's all about which one is the best for the right task. This is a critical review. So these are my opinions. These are things that I learned. This is how I think about it. So your mileage may vary. Do your own research, maybe based on this framework as well. So API styles. I promised to cover 8 styles here. And that's a lot for 20 minutes, right? So your head might be spinning in the end, but I hope it will still be helpful. Now, important thing to mention here. This is comparing apples and oranges and bananas. This is API styles, but some of these are actually API architectural styles, some of these are frameworks, and some of these are protocols. So there is quite a big difference. However, at the end of the day, you still need to pick one of these for your next API, right? I would say if you are a modern architect, this is the minimum you should know, you should consider when you'll be thinking about your next API project. The important thing to understand is that these styles are coming and go. They are changing over the time, and also their trendiness. So if you do a simple Google Trends query, this is what you might end up with. You see that web services SOAP was very popular back in the days. Now it's about, according to Google, popularity of a GraphQL search queries. And REST is somehow stagnating, and emerging gRPC, Kafka, and GraphQL, of course. This has to do with what I call a paradigm shift. We were historically, at the inception of APIs, we were doing point-to-point integrations. You had a big industry, it partnered with somebody, they did a one-to-one integration, one provider, one consumer. That was about it. I call this a customer-specific APIs. We moved towards a more generic APIs, where providers realized that there is a value in having multiple consumers consuming one interface instead of doing point-to-point. That's where we are. We are transitioning to harmonized APIs because clients nowadays are consuming usually more than one API in their code, right? That's why you start to see this third-party vendors, these harmonization layers in between the communication. They are harmonizing maybe APIs from one domain. So this is what I call harmonized APIs. Now, we are about to get and enter the new era of APIs. I call this autonomous APIs, where clients and servers will be totally decoupled. They will be able to navigate the landscape and find and consume the services as they want. Recently, we made a very, very big breakthrough in this area. I cannot wait to share announcement later this year. I still need to finish some research, but I think there is something very interesting about to happen very soon. Going back to our architectural styles. So what is the API architectural style? It is very simple. It's just a set of constraints that, upon applying, are giving your system with certain properties. Let me explain. When you have a decoupled constraint, so you are constraining your system to a system where components are not tied together, they are decoupled, you are enabling evolution. You are enabling modifiability. That's a very simple example. More complex, one constraint, statelessness, can give you 2 good properties, actually. One is reliability. So if you have a stateless communication, you can easily repeat the calls, right? It's more reliable, at least the idempotent calls. And also, you are enabling scalability, because simply, the server doesn't have to remember the state of the client application. However, some constraints can give you also a bad properties of your system. So uniform interface is making it much easier for clients to consume and navigate in an API, right? It gives you the simplicity, solving the complexity problems. But because it's this intermediate layer, it sort of degrades the efficiency, right? So it's important to understand that this is also, the constraints might also imply properties that you are not really all that excited about. Now, we are happy case programmers. I'll be just talking about the good properties for the rest of this talk, okay? Architect. So if you are an architect, your job is very simple, right? Well, except it isn't. But one of your jobs is and should be to understand these styles and pick the right one based on the input, right? Based on the use cases that your API product should fulfill. Now let's talk about these constraints. And for that, I need to bring the physical architecture, the colonial homes, and explain how these constraints really work. The colonists were not thinking, hey, I really like this architecture. I think I'll build some colonial homes. They were constrained by the environment and the technology they had. For example, Windows. The windows on these homes, they were from a small pieces of glass. They couldn't produce a big glass window. It was beyond their technology. It was too complicated. And even if it would not be too complicated, they would probably break it during the transportation on a horseback or wagon, right? So in other words, these people were constrained by their environment, by their technology to produce colonial architecture. They were not doing colonial architecture because they liked it or not. They were constrained by the environment to produce what maybe some of us think as a beautiful homes. Important message here, listen to your constraints. Don't be like, hey, I like really this Kafka APIs. I think I'll build one. That's a very wrong approach. You should be really thinking, oh, okay, what are my constraints where I am? What style am I going to build? There are two broad areas of these constraints, one on the product side and one on the actual architectural side. So the product side is controlled by a product owner, the environment, the culture, your company. The architectural style, those are the technical constraints of a particular style. It works like this. Maybe your product owner asks you to build a product, an API that has a lot of external customers. And there will be many releases, right? That's a constraint coming from a product owner. You as an architect have to think about it and say, oh, okay, this means that I need to do the decoupling. There will be a lot of people, a lot of consumers. I have no control. I cannot coordinate the deployments. I need to constrain the system to a decoupled system. Why? Because if I do this, I get a system which I can evolve. Because the product owner told me that there will be a lot of versions and there will be people I have no control from, right? That's why you need an API style that gives you evolvability, right? So what are these constraints from the product side? The business constraint, that's where you have your product requirements, both functional, non-functional, costs, time to market, of course. If your API product will be on the market just for one conference, then you probably need some style that makes it very easy and doesn't care too much about evolution, right? And of course, the fundings, I already mentioned that. Also, customer constraints are important. If your customers don't understand anything, but just they can read one Excel, then good luck on convincing them on jumping on Kafka, right? So that's also constraining your decision on the API style. Domain constraints, that's simply the environment you are in, right? So you might have some governmental regulations, you might have some limitation of your domain, the transportation, shipping domain for sure have some regulation and constraints. So these are also things you need to consider when thinking about your API style. Cultural. This is probably the most popular for making a decision on API styles. Well, trends hype, so this hype curve and popularity of some API styles makes people to decide for a particular API styles. But it goes all the way to leadership support. It goes all the way to existing investments. If your teams are all Java developers heavily invested in ESB infrastructure, then it will be maybe harder to pull for them, a different, modern API style. In other words, this is going back to Mel Conway's law about that we are destined to build the systems that are basically copying our organizational structures. As Elon Musk recently said, product errors are basically copying organizational errors. Complexity constraints, last set here, how difficult it is to do some task in your application. This is also about the scaling and chaotic and unpredictability complexities and algorithmic complexity, both in the sense of traditional mathematical algorithmic complexity, but also in the sense of cognitive, how hard it is to understand an algorithm in your API. So these are the constraints of API product. Now, these should translate to constraints of an API style itself. So what you see here on the screen, these are 6 constraints of an API style. As a matter of fact, this is what REST is. Only these 6 constraints, that's a REST architectural style. These 6 things, if you follow, you will get a REST API system, API and distributed system, which gives you certain properties. That's it. This is all that REST is. Now, what are these properties then? I'll just list some properties you might be interested in. Of course, there might be other properties of a system that you are building that you would like to get. Performance, that's very obvious, but it's more contrived than just saying performance. You can have a network performance, a network efficiency. You can have user-perceived performance, which is something very different to being efficient over the network. Scalability, simply how many components you will have in the system. That's maybe a property that you care about if you build a system that has a lot of clients. Maybe you don't care about it because you have just one-to-one scenario. You are building a backend for the front end. Simplicity of the uniform interface. This is not how easy it is to build that API style. This is how easy it is for clients to handle the complexity issues within the distributed systems. To build a simple APIs, it's not an easy task. Okay, so don't mix these two. Modifiability. This is the popular topic. That's the versioning. Like, if you ever had struggles with the versioning, then you probably didn't pick an architectural style that gives you the property of the system modifiability. Okay, visibility of the interactions between the components. Can I poke inside? Can I have a load balancers, proxies, gateways in my system? That's the visibility between the components. Portability, moving from environment to an environment. Reliability, discoverability, type safety, those are other properties you might be thinking about. Also, as I already mentioned, the ease of development and, of course, cost, how expensive it is, both in the money and time wise. There are some considerations of the ecosystem itself, not just the properties of the system, but the ecosystem around that API style, right? Those are very important. They are more social than the technical constraints or properties of the system. These are maturity. Is this API style mature? Maybe for somebody it's important whether it's ready for enterprise or it has a great tooling. There is active community, right? That would be ACI. Resources, books, publications, and last but not least, how difficult is this to monetize, externalize the API? Or the API product using that API style. Important message here, every product is different and need different properties. It doesn't make sense that everybody's doing REST or GraphQL based on your properties, right? The recipe is very simple. You just think about the properties you want to get and maybe the consideration of the system and you pick the right style, right? I'll give you examples. This would be for REST. If you care about scaling, if you care about versioning and modifiability, you pick REST, right? It's probably not all that great if you want ease of development or super simple tooling. For that, we have a GraphQL. If you want amazing tooling system that can be really quickly put together. Just don't bother yourself with REST, right? We'll go more in depth in these, but this is how it works. Think about the properties and consideration. Understand which style gives you what. All right, so we have 10 minutes left, 8 styles to do, right? That will be easy. So starting with the REST. It's a buzzword. It's a very popular word to be used. Most of the APIs are not following the REST constraints. Everybody knows that. This is the constraints, the properties, and the consideration of a REST API. So as I said, if you follow all these 6 constraints in your system, you will get more or less these properties. That's the promise. That's the promise that Roy Fielding made. This is, follow these constraints, you'll get that. Maybe you don't care about it. Maybe you care about cost and ease of development and time to market, right? What if? So use the REST if you want to build a system that lasts. If you need a content negotiation, if you have different media types, HTML, XML, JSONs, that's where REST is really strong. If you need to scale, like the best example of REST is World Wide Web. That's scaling beyond anything, right? That's a system that's so performant and scaling and hard to kill that it's actually not possible. So if you care about that properties, think about REST. Then there is so-called REST, right? That's REST, but not really, because uniform interface constraints, it's not fulfilled. That's what most of us are doing when we are building the REST APIs. Why? Because we get all the other constraints if we follow HTTP protocol correctly. HTTP protocol doesn't cover a uniform interface, and that's why we usually tend to skip it. If we skip it, we'll get a system which has some good properties, but it definitely doesn't have modifiability. It's hard to evolve such a system. I would say, do not use so-called REST. Either use REST, or if you are having some special use case, think about the GraphQL. Speaking of which, GraphQL, an RPC tunneling query language, which recently got a lot of interest, a lot of traction, and it has amazing tooling. It has amazing developers experience. I would say it's a great tool, especially in the scenarios when you are talking to yourself, meaning you are building a backend for front end, you have one consumer, and that's just an amazing tool to use. It's super simple to set up, even simpler to consume. It doesn't scale well. It has some versioning incorporated, but it doesn't evolve as well as the rest. But the tooling and commit is amazing. If you need to set up something quick, if you don't know the use cases for sure, aka you don't know what users actually want, well, you should have a product owner. But if you don't know it, then you might use GraphQL as a help to collect the feedback on what people actually want from your API. Moving on, a very different style, actually a framework. This is Apache Kafka, very trending right now. Almost, I would say, at least in my environment, more than GraphQL. It's a publish-subscribe framework, which offers amazing performance. If you need a publish-subscribe capabilities, and you need it blazingly fast, reliable, scalable, Kafka is amazing, except it has a few problems. It's heavily based on Java. You have to have a Java knowledge. So if you are a Node.js shop, it will be harder for you to pull off. It's not all that great if you need to externalize that interface. There are ways to do it, but probably not the best thing right now. It is maturing in the tooling. So again, if you need super performant publish-subscribe scenario, then think about Kafka. You have to have a Java developers. You have to understand the Java world. If you are not coming from the Java background right now, it might be a little bit tough for you to pull off. So that's back to our cultural constraints, right? If you are not Java, then it's constraining to probably not use Kafka. Moving on, another publish-subscribe mechanism called WebSub. A very different thing. It enables publish-subscribe. It is a W3C standard. Not that many people know about it. Not that many people are using it. But this is a publish-subscribe mechanism that is standardized, that is inheriting everything from REST and Atom and news feeds. And it is pretty good in externalizing publish-subscribe capabilities. It's nowhere performant as Kafka. There is no denial on that. But it's super easy to use it if you need to externalize some publish-subscribe notifications. And maybe, moreover, externalize it on top of an existing REST API. So again, use WebSub if you want to do a publish-subscribe, and this API should be public, should be productized, it should be your product, right? Okay, web services show up, the thing that has been with us for a long time, and it still is. It's probably powering everything that you did on your way here. So purchasing the tickets, doing the payments, booking a hotel. It's all web services. All the enterprises are still heavily relying on SOAP protocol. It's RPC style again, so it's not really bringing all that much in the terms of a modern developer. However, it still has its uses. If you have consumers that are asking for it, if you have a culture, that means you have invested in ESBs and all that, it still might make sense for you to pull a SOAP web service API. However, I would advise to really consider the other styles, because this will eventually fade out. And again, this is point-to-point integration mostly. I've seen some very nicely crafted SOAP APIs with the developer portals, but it's really a long stretch to use it for that. gRPC, a modern RPC API style or protocol or framework, actually, backed by Google, amazing performance. If you need RPC, again, RPC is a strong canon. Like, you need to really know what are you doing and why, and you need to reinvent a lot of things that are already coming from with REST or HTTP or even GraphQL. So gRPC is for people who really count every single byte. If you are in that situation that every single byte matters, you need a strong type safety, you need just amazing performance, and you don't care that you need to reinvent a couple of things along the way, then go ahead, use gRPC. It's not all that great for web browsers. It is possible to consume gRPC service in a web browser, but if you are thinking about the web application backed by gRPC, I would probably suggest look at the GraphQL or REST. So that's gRPC. And one last thing I want to mention, the file transfer. Don't forget about it. If you are an architect, sometimes it is not all that much on that architecture. Maybe enterprise readiness of a file transfer, I don't know. But it still makes sense in a scenarios where you do a batch processing, where you don't need real-time capabilities. A good example I'm always giving is that that's one of my amazing clients, Adidas. There was an HR team who wanted to build, I think, payroll API. So we designed a nice REST interface. It was all beautiful design, right? Perfect. But then I asked, okay, why do you really need it? And it turns out that there are these payroll processing companies that all they do is just once a month they download all the data and just batch process it, right? Well, you probably don't need a real-time form of communication for that. If all they do, they just call that API once a month, try to get everything, and they just do their batch processing on their side. So just keep it in mind that it is an API. It has a lot of things why you probably don't want to use it, but just don't say, hey, this never makes sense. There might be a situation when just dump the file, throw it over the fence might be actually a better choice than building something really, really beautiful and complex. So all in that, always decide based on your constraints and properties you want to get, because you are unique. So that's the message here. Before I finish, I had the pleasure to do a foreword for this amazing book by my friend Luis. There are 4 books that I want to give away here. So first 4 of you who will come after this talk to me, I'll give you the books. So come and pick up the book. Thank you very much.